I'm your OLC from Engineering Department. Good morning. Okay, let's start with a description of a diode is one of the application of the PN junction. In this module, the characteristic and operation of a diode will be discussed. Its ability to conduct current in one direction is essential to the operation of many types of circuits. Then this chapter also discussed the diode and some of its application. Okay, let's start. And the conclusion of this learning module, the students are expected to discuss diode and its operation. Then number 2, discuss forward reverse bias and explain the voltage current characteristic of a diode. Then we will also discuss the different diodes model. Okay, let's start. Diode is a semiconductor device with a single PN junction that conducts current in only one direction. Then anode is the P region of the diode and cathode is the N region of the diode. Okay, as you can see, meron tayong dalawang region ng diode wherein anode ito yung sa schematic symbol ng diode, then sa cathode naman is in this side. Okay, wherein as you can see, a diode is a semiconductor device with a single PN junction that conducts current in only one direction. Okay, yan yung definition ng diode. Okay, the diode operation is a two-terminal semiconductor device formed by P-type and N-type semiconductive materials. It is separated by a PN junction. As you can see, these are the PN junction nagse-separate dun sa P-type at saka N-type semiconductor materials ng diode. Kaya ito ay meron two-terminal semiconductor device. Okay, that's the P-type and the N-type. In this module, you will learn how to use a voltage to make the diode to conduct current in one direction and block it in the other direction. Okay, ito yung application ng diode. Usually, it is used voltage to make the diode conduct current in one direction. Okay, yun yung application niya, application ng diode, that is to conduct current in one direction. Then, pwede rin namang mag-block it in the other direction. Okay. Then another application of a diode is the application of a DC voltage to a diode to make it either conduct or block currents called biasing. Okay, may tinatawag tayong biasing. It is depende kung conduct, ibig sabihin, it allows the flow of current. Or kung ibablock naman yung current. Okay, yun yung application ng diode. Once na nagkameron ng application ng DC voltage to a diode, pwede siyang maging tawag ito, forward or reverse bias, or depende sa biasing kung ito nga ay magko-conduct or magbablock ng current. Okay? Now we will discuss the forward bias. What is a forward bias? Forward bias is the condition that allows current through the PN junction to have a forward bias, an external voltage wherein the negative side is connected to the N region of the diode and the positive side is connected to the P region. Okay, para magkameron ng tinatawag nating forward bias is ang external voltage wherein the negative side, yung negative side ng external voltage is connected to N region of the diode. Then yung positive side naman is connected to P region. Then magkakameron na ng forward bias. Ang forward bias kasi is ito yung condition that allows current through the PN junction. Okay? Then, para makuha itong condition na to ng forward bias is kailangan the bias voltage or B bias must be greater than the barrier potential. Okay, meron tayong tinatawag na barrier potential kasi. Kasi dapat yung bias voltage na B bias is kailangan mas mataas or must be greater than the barrier potential ng diode. Okay, para makuha yung condition na forward bias. Okay, next later, we will also discuss, it depends on the semiconductive materials or ng diode kung ano yung value ng barrier potential niya. Nito. Okay, next. As shown in the figure, Okay, meron tayong figure. As you can see, meron tayong P region at saka N region. As shown in the figure, a DC voltage source is connected across a diode in the direction to produce a forward bias. As you can see, we have meron tayong DC voltage source, okay, B bias. Okay, this one, meron tayong DC voltage source, battery, is connected across a diode, ito yung diode, in the direction to produce a forward bias. Then, the external voltage is designated as V bias. Okay, ito yung V bias natin. Ito yung external voltage. Then, the resistor that limits the forward current to a value that will not damage the diode is designated as R limit o yung resistor limit. Okay, meron tayong tinatawag na R limit or resistor limit. Ito yung the resistor that limits the forward current to a value that will not damage the diode is designated as a R limit. Okay, para hindi masira or ma-damage yung ating circuit or yung diode, is meron tayong tinatawag na R limit. Okay, that's the function. The resistor that limits the forward current to a value that will not damage the diode is designated as this one, R limit. Okay. Okay, as now we have a figure to show what happened when a diode is forward biased. In the figure above, ito yung nangyayari kapag naka-forward bias ng diode. Okay? For example, condition, since like charges repel, okay, pag parehas yung kanyang charges is nagre-repel. Okay, pag parehas, that is repel, kaya nga kung magkaiba is nag-a-attract naman siya. Okay, since like charges are repel, then the negative side of the bias voltage source is pushing away the free electrons, which are the majority carrier in the N region, towards the PN junction. Okay, as you can see, alam naman natin kapag like charges is nagre-repel, then sa negative side, this one, of the bias voltage source is pushing away the free electrons, which are the majority carrier ng N region, towards, papunta dito sa PN junction, towards the PN junction. Then, the negative side of the source provides a continuous flow of electrons. Since nagkakameron ng continuous ng flow of electrons, ibig sabihin nagkakameron ng conductor or conduct. It allows the flow of current. Okay? Or nagkakameron ng current. Okay, then, ang mangyayari naman, the bias voltage source provides a sufficient energy to the free electrons to overcome the barrier potential of the depletion region and to move across into the P region. Then, the free electrons have lost enough energy and will combine with holes in the valence band when they get to the P region. Okay, as you can see, yung bias voltage source is nagpo-provide siya ng sufficient energy papunta dun sa free electron para ma-overcome yung barrier potential ng depletion region and to move across into the P region. Then these free electrons have lost enough energy and will combine with holes in the valence band when they get to the P region. Okay? Okay, now, ang mangyayari naman ulit, since unlike charges attract, okay, pag hindi magkaparehas ng polarity or ng charges is mag-a-attract, ang mangyayari sa condition na to is the positive side of this bias voltage source will attract the valence electrons toward the left end of the P region. Then the valence electrons move from one pole to the next toward the left, as shown in the figure 2.3. Then the holes, which are the majority carriers in the P region, okay, ang majority carrier dito is yung holes, ang mangyayari is will move to the right toward the PN junction. Okay? Okay, now we will discuss the effect of a forward bias on the depletion region. Ano ba yung epekto ng forward bias sa depletion region? Okay, now we will discuss. During the forward bias in an N region, more electrons flow into the depletion region and the number of positive ions is reduced. In P region, more holes effectively flow into the depletion region and the number of negative ions is reduced, as shown in the figure below. Then the reduction in positive and negative ions during the forward bias cause the depletion region to narrow. As you can see, ito yung effect ng forward bias. Sa forward bias is N region, this one. Ang nangyayari is more electrons flow into the depletion region and the number of positive ions is reduced. Okay, yun yung nangyayari pag forward bias. Tapos sa P region naman, ang nangyayari is more holes effectively flow into the depletion region and the number of negative ions is reduced kasi nga naka-forward bias. As you can see in the figure, this one, reduction in positive and negative ion during the forward bias. Then it will cause the depletion region to narrow within depletion region. Kaya sobrang liit na siya. Kasi nga yung nagkakameron ng reduction in positive and negative ions. That is during the forward bias. Now we will discuss the effects of barrier potential during a forward bias. Okay, ano naman ang effect ng barrier potential during a forward bias? Okay, when forward bias is applied, the free electrons are provided with enough energy from the bias voltage source to overcome the barrier potential and effectively cross the depletion region. Then the barrier potential is equal to the energy that the electrons need to pass through the depletion. Then when the electron pass the depletion region, they lost the energy and equal to the barrier potential. Okay, ang energy loss kasi in the voltage drop across the PN junction is equal to the barrier potential. Ang voltage drop ng silicon is equal to 0.70 volts. Okay, constant yan. Okay, ibig sabihin ito yung voltage drop na ang silicon, that's 0.70. Okay, kapag nag-apply tayo ng forward bias, yung free electrons are provided with enough energy from the bias voltage source to overcome the barrier potential. Then it is effectively cross the depletion region. Okay, next. Okay, ano naman ang nangyayari kapag reverse bias? Kapag reverse bias, it is the condition that essentially prevent current through the diode. Okay, kung sa forward bias is nag-allow tayo ng allowed to pass the current through the diode, dito naman is nagli-limit tayo or piniprevent natin. Piniprevent nito ang current through the diode. Okay, ito yung tinatawag na reverse bias. To have a reverse bias, an external voltage wherein the positive side is connected to the N region of the diodes and the negative side is connected to the P region. Okay, kapag tinawag nating reverse bias na condition is yung sa external voltage wherein yung positive side is connected to the N region. Kabaliktaran naman dun sa forward bias. Then yung negative side naman is connected to the P region. Then mangyayari na yung reverse bias na condition. Okay, next. As shown in the figure below is a DC voltage source is connected across a diode in the direction to produce a reverse bias. Okay, makikita natin yung positive is connected with the N region. Then yung negative bias naman dito, ng B bias, is connected with the P region. Going to P region, then we have the R limit here. The external voltage is designated as a B bias. Okay, ito yun. Then in reverse bias, there is actually no current. Okay, since no current yan, limiting the resistor is not important. Kahit hindi ka na maglagay ng limiting resistor dito. Kasi ang condition sa reverse bias is there's actually no current. Then the depletion region is much wider than in a forward bias or in a equilibrium. Okay, makita natin ang depletion region dito sa reverse bias is much wider, mas malaki compared dun sa kanina na forward bias. Okay, sa reverse bias, okay, much wider than in a forward bias, mas malaki. Okay, yung depletion region. Okay, now we will discuss to show what happened in this reverse bias. As you can see, this is the figure. Okay, ang nangyayari dito, since unlike charges attract, the positive side of the bias voltage source pulls away the free electrons that are the majority carriers in the N region from the PN junction. Then additional positive ions created as the electron pass toward the positive side of the bias voltage source. Then this makes the depletion regions widen and the depletion of the majority carrier. Okay, ganun yung nangyayari. Okay, sa reverse current, ano naman yung tinatawag nating reverse current? Sa reverse current, as shown in the figure below, the few minority free electrons in the P region are pushed toward the PN junction by the negative bias voltage. Then they combine with the minority holes in the N region when they reach the depletion region as a valence electrons and then flow towards the positive bias voltage and creating a small hole current. Ito yung nangyayari kapag nagkakameron ng reverse current. As shown in the figure, we have a few minority free electrons. Ito yung mga free electrons, kakaunti na. Okay, that's the free electrons, negative, in the region, in the P region, in this one. Okay, ito na yung minority free electrons in P region. They are pushed toward the, papunta dito siya sa depletion region. Okay, they are towards the PN junction by the negative bias voltage. Okay, they are pushed or towards the PN junction by the negative bias voltage. Then after nun, they combine with the minority holes in the N region naman when they reach the depletion region as a valence electron and then flow towards the positive bias voltage. And this will creating a small hole current. Okay, yan yung nangyayari. Nagkakameron ng small hole current. Then continuation, the conduction band in the P region is at a higher energy level than the conduction band in the N region. Therefore, the minority electrons easily pass through the depletion region and because they require no additional energy. Okay, nangyayari, doon sa tinatawag natin sa conduction band in the P region, this one is at a higher energy level than the conduction band in the N region. Therefore, yung minority electrons easily pass through the depletion region because they require no additional energy. Okay, next. Okay, ano naman yung tinatawag nating reverse breakdown na condition? Okay, ito yung reverse breakdown condition. The reverse current is neglected because they are relatively very small. However, if the external reverse bias voltage is increased to a limit called the breakdown voltage, the reverse current will drastically increase. Okay, meron tayong tinatawag na condition na reverse breakdown. Okay, sa condition na reverse breakdown is or nagkakameron ng reverse breakdown voltage kapag yung reverse current is neglected because they are relatively very small. However, yung external reverse bias voltage is increased, tumataas. Since tumaas yung external reverse bias voltage, is mag-i-increase ito dun sa limit. Since nag-increase ito sa limit, yung external reverse bias voltage is nagkakameron ng breakdown voltage. Then, ang mangyayari dun sa reverse current will drastically increase also. Kasi nga tumaas din naman yung external reverse bias voltage. Lumabas siya dun sa limit na voltage. Kaya nagkameron ng breakdown voltage or yung reverse current will drastically increase also. Okay, then the pre-minority electrons that acquire energy from the high reverse bias voltage will go through the P region and collide with atoms with the right amount energy to knock valence electrons out of orbit, which become conduction electrons. Then the newly created conduction electrons are high in energy and repeat the process. Then the repeated process will have a conduction electrons multiply. Okay. Okay, continuation. As these high energy electrons go through the depletion region, they have enough energy to just pass through the N region rather than combining with holes. Then the multiplication of conduction electron is the avalanche effect. Okay, meron tayong tinatawag na avalanche effect kapag yung high energy electrons go through the depletion region and they have enough energy to just pass through the N region rather than combining with holes. Then, meron tayong tinatawag na avalanche effect. Ito nga yung multiplication of the conduction electrons. Then, the reverse current can increase dramatically if current is not limited. Okay, pwede rin tumaas yung mga reverse current, increase dramatically kung wala naman tayo, kung hindi naman nalilimit yung current or wala kang masyadong ginamit na resistor, limit or R limit. Then when the reverse current is not limited, wala kang ginamit na resistor limit or R limit. Kung hindi naman yung reverse current is not limited, the resulting heating will permanently damage the diode. Okay, yung disadvantage. Since wala kang ginamit na R limit, yung reverse current is mag-i-increase. Then reverse current will also result to a heating or iinit yung magkakameron ng heating. Then this heating will have a permanently damage the diode. Okay, yan yung disadvantage kapag walang R limit. Then most diodes are not biased in the reverse breakdown, but if the current since usually mga diode is hindi siya are not biased in a reverse breakdown, but kung meron ka namang limit na nilimit mo yung current, but if the current is limited by adding a series limiting resistor, there is no permanent damage to the diode. Okay, yan yung advantage ng paggamit ng series limiting resistor. Okay, para hindi ma-damage yung ating ginagamit na diode. Okay, now we will discuss the voltage current characteristic of a diode. As you can see, we are in the condition called the forward bias. So forward bias conducts current through a diode. Then kapag reverse bias, it prevents current. Then the reverse bias prevents current as long as the reverse bias voltage is not equal or greater than the breakdown voltage. Okay, ito naman yung voltage versus current characteristic for a forward bias. As you can see in this figure, as shown in the figure is the graph of a voltage versus current characteristic curve of a forward bias diode. Then the forward voltage VF increases to the right along the horizontal axis, and the forward current IF increases upward along the vertical axis. Okay, sa condition natin yung forward voltage increases to the right. Okay, yun yung VF, ito. Pataas yung increase niya as you can see in the figure. Then yung tinatawag naman nating IF or yung forward current is increases upward. Itong vertical, usually unit is in milliamperes. Okay, as the forward voltage VF reaches approximately 0.7 dito, across the PN junction at the knee curve, the forward current, ito yung IF, only increases very little. Sobrang little lang yung increase. Nakikita natin, tumataas to. Forward voltage reaches approximately 0.70 volts. Then across the PN junction at the knee curve, ito yung knee curve. Okay, ABC. The forward current IF, okay, increase lang siya. Only increases very little. Then after this point, the forward current IF increases rapidly since na-reach na yung 0.70 volts. Increases rapidly while the forward voltage is nearly constant at 0.70 volts. Okay? Yan yung voltage current characteristic for a forward bias. Okay, now we continue. As shown also in the figure is the 3 points A, B, C point. Okay, ito yung point A, point B, and point C. At point A is the zero bias condition, 0 volts pa lang, tsaka 0 yung IF. Okay, then the point B, this one, is where the forward voltage BF is less than the barrier potential of 0.70 volts, And the forward current increases very little. Okay, tumaas lang ng konti yung IF natin dito. Okay, then the BF, where the forward BF, ito, is less than the barrier. Mababa pa rin sa 0.70 yung barrier potential. Then ang forward current, ito, IF, increases very little. Okay, pagdating naman sa point C, as you can see, point C is where the forward voltage, ito yung BF, approximately equal the barrier potential. Okay, equal na siya sa barrier potential na 0.70. And the forward current, IF, okay, significantly increased. Tumaas na rin yung IF natin dito. Okay, that is the voltage current characteristic for a forward bias. Okay, now we will discuss the dynamic resistance. Okay, what is a dynamic resistance? As shown in the figure below is the expanded view of the graph of a voltage current characteristic curve of a forward bias diode and illustrate a dynamic resistance. Okay, then the resistance of a forward bias diode is not constant over the entire curve because the resistance changes along the voltage current curve. Then the resistance called the dynamic resistance or AC resistance. As you can see in the figure, okay, ito yung sa voltage natin na BF. Then meron tayong tinatawag na dynamic resistance or AC resistance. It is the resistance of a forward bias diode. It's not a constant over the entire curve. Hindi siya constant kasi nagbabago-bago. Because the resistance changes along the voltage current curve. Okay. Continuation. Dynamic resistance. Internal resistance is the same design by a lowercase italic r with a prime. Okay, yan yung ginagamit na symbol or letter. Then the dynamic resistance of a diode is designated as RD. Then the resistance greatest below the knee of the curve because the voltage increases significantly but the current increases very little. Okay, ang formula ng RD natin is, kung familiar kayo sa Ohm's law, ito yung ginagamit natin. That is, ang Ohm's law kasi is B equals to IR. Then, para makuha lang natin yung R, that will become voltage over current. Okay? Or change in BF, or yung BF natin is yung tinatawag na forward voltage. Then divide it to the change in IF. Yung IF natin is yung tinatawag nating forward current. Okay? Ohm's law lang din. Okay, then the resistance begins to increase. The resistance begins to decrease and become smallest above the knee of the curve because where there is a significant increase in a current for a given change in voltage. Okay? Okay, as you can see, these are the voltage current characteristic for a reverse bias. As shown in the figure is the graph of a voltage current characteristic curve of a reverse bias diode. The reverse voltage BR increases to the left along the horizontal axis, and the reverse current IR increases downward along the vertical axis. Okay, ito yung BR natin. Okay, increases to the left. Okay, papunta doon. Okay, habang tumataas yan along the horizontal axis, yung reverse current na IR naman, unit is in microamperes, increases downward. Okay, pababa along the vertical axis. Then there's a very little reverse current which is usually microamperes or nanoamperes. Okay, sobrang liit lang ang value ng reverse current. Until the reverse voltage across the diode reaches approximately the breakdown voltage, BVR, at the knee of the curve. At this point, the reverse voltage BR remains at approximately BVR, but IR increases very rapidly, resulting in overheating and possible damage if current is not limited. Okay, that is the voltage current characteristic for a reverse bias. Okay, kabaliktaran lang dun sa forward bias. Ito naman is pa-downward, pababa. Okay? Then, anong nangyayari kapag since sobrang baba ng value ng reverse current, which is usually micro and nanoampere, until the reverse voltage across the diode reaches approximately the breakdown voltage VBR at the knee of the curve. Okay? After this point, the reverse voltage VR remains at approximately VBR. Okay, katulad lang ni kanina. But kapag nag-increase rapidly naman yon, itong reverse voltage is nagkakameron ng overheating and possible damage if current is not limited. Okay? Okay, ito naman yung tinatawag nating voltage current, breakdown voltage. Okay, ano ba yung breakdown voltage? The breakdown voltage for a diode depends on the doping level. A typical rectifier diode has a breakdown voltage of greater than 50 volts. Usually, kapag yung mga typical na rectifier diode, ang mga value ng breakdown voltage is greater than 50 volts. Then, some specialized diodes have a breakdown voltage naman is only 5 volts. Okay? Okay, as you can see, we have a complete PI, voltage current characteristic curve. Okay, pinagsama na yung forward at reverse bias. As you can see in this figure, these are the forward bias. Yung meron siyang papunta sa vertical pataas. Then sa kabila naman is yung reverse bias. As shown in the figure below is the combination of the curve for both forward bias and reverse bias, which is the complete voltage current characteristic curve for a diode. Okay, now we'll have a connection for a forward bias connection. As shown in the figure below, the positive terminal of the source is connected to the anode. Okay, yung positive terminal, review lang din ito kanina, katulad lang din. Yung positive terminal ng source is connected to the anode, yung sa positive, through a current limiting resistor. Then, doon naman sa kabila, the negative terminal of the source is connected to the cathode. Okay? Then the forward current, IF, is from the cathode to anode. Then the forward voltage drop, BF, is due to the barrier potential is from positive at the anode to negative at the cathode. Okay, yung connection ng forward bias connection. Okay, these are the circuit. Okay, sa reverse bias naman is kabaliktaran naman sa forward bias. Sa reverse bias, as shown in the figure below, yung negative terminal of the source, this one, is connected to the anode. Okay, dun sa positive side. It's connected to the positive or connected to the anode side of the circuit, and the positive terminal is connected to the cathode side. Okay? A resistor is not necessary in reverse bias since hindi naman kailangan natin mag-limit ng current since there's no current or naka-block yung current dito through reverse bias connection. Then the reverse current is extremely small and approximately zero. Then the entire bias voltage, V bias, appears across the diode. Okay, direction na siya. Kahit wala na itong resistor. Hindi na not necessarily in reverse bias. Because the reverse current is extremely small and approximately zero. Okay, next. Okay, now we will discuss the ideal diode model. Okay, ito yung mga ideal model ng diode. Ideal diode model. The ideal diode model is represented like a simple switch. As shown in the figure above, it is ideally like a closed switch or a switch that is on when the diode is forward biased. Okay, ito yung tinatawag na ideal diode natin. Katulad lang din siya ng mga simple na switch. Katulad dito sa figure na to. For example, pwedeng closed switch or a switch that is on. Pwedeng naka-on din siya when the diode is forward biased. Kapag naka-on yung switch, katulad dito, Ibig sabihin, naka-forward bias yan. Or nag-allow ng flow of current. Okay, dito naman, kasi dito is naka-on siya or on switch, kaya naka-forward bias or allow the flow of current. Dito naman sa model na to, or sa schematic symbol, circuits, as shown in the figure, this one, it is ideally like an open switch or a switch that is off. Okay, naka-off yung switch. Ang ginagamit na dito na condition is kapag naka-reverse bias. This model is the least accurate approximation. In the ideal diode model, the barrier potential, then the forward dynamic resistance, and the reverse current are all neglected. Okay. Okay, for example, in this figure, as shown in the figure above, is the ideal voltage current characteristic curve. Graphically, depicts the ideal diode operation. The diode is assumed to have a zero voltage across it. Then the barrier potential and the forward dynamic resistance are neglected when a forward bias as indicated by the portion of the curve on the positive vertical. Kaya yung condition kapag ideal model. As you can see, there's the forward bias. Okay, naka-value siya. Ibig sabihin naka-on ang switch niya or nag-allow ng flow of current. Then kapag reverse bias, dito naman yung sa kanyang voltage. Okay, ibig sabihin may value dito or nagkakameron ng block ng current. Okay, then zero yung sa current.